All right, so today we want to cover procurement methods. We've got design bid build, we've got design build, we've got CMGC. There's even some modifications, some combinations of each of those. So first of all, why don't we turn into this set of plans and we'll look at a design, or you know what? Why don't I just take you and show you some projects? All right, so here we are at Mendon Road. And this is the first of several projects I want to show you today. It used to be a tradition that we would take seniors on a field trip somewhere at the end of their senior year. And I'm not entirely sure when that tradition went away or why, but I figure with the way that things are right now, I get to take you on a virtual field trip. So we're going to look at a couple of different projects today, starting with this one. It connects Mendon with Logan, and it is in quite the scenic little spot. But in 2016, all of the area that you see out there was under several feet of water. In fact, the bridge itself was under about a foot of water initially, and by the time we got a chance to come out and look at it, the bridge, not this bridge, but a different bridge, had settled. So it had gone from that elevation and had dropped about 18 inches. And so there was a bump on either side of the road here of about 18 inches down. So, of course, they had to close the road. It was important to reconstruct the structure and reestablish this link as soon as possible because, hey, how else are people going to speed by here at 70 or 80 miles an hour? So one of the major issues that we faced was having this whole wall of water over here that we needed to stop, at least temporarily, while we reconstructed this structure. The original structure was a three-sided structure supported on essentially rock foundations, and I think that those rocks had largely washed out or otherwise displaced, and so that's what caused the structure to drop several inches, 18 inches, as I said before. So we undertook this project as a CMGC project, which means it was a contract manager general contractor project. In a CMGC project, an owner hires an engineer and a contractor to collaboratively work out the design details. Once they're satisfied with the plans, the contractor takes those plans and constructs the project. Let's look at an overview of the CMGC process really quickly. An owner would engage in this process by competitively selecting a designer and contractor as a team to design the project before it goes into construction. They would base this selection on the team's qualifications, their experience, the innovation that they bring to the project, and then certain cost elements in the project construction cost itself. The timeline for this means that the contractor is involved in the design right from the beginning, so the designer and the contractor can collaborate on designing the actual project prior to releasing any documents for construction. This is a good thing because we can get the contractor's opinion on what's most constructible and what might be easiest or what might be most innovative before we ever take it out to the field for construction. The biggest advantage of the CMGC process is the allowance for innovation during the design because of collaboration with the contractor. Other things that you gain from this, though, are reduction in errors, reduction in change orders, and you get a more certain cost when you're done with this process. It also identifies and manages risk. You get higher design quality, and it helps to optimize the schedule. One of the big limitations, though, is understanding when it's appropriate to use this process versus a traditional design bid build process. One of the other risks to this situation is that you may incur additional fees due to having a third party review the costs that come back from the contractor to verify that you're getting reasonable prices. Usually, though, this cost is more than offset by the savings that you get by involving the contractor right from the beginning. So in addition to the fact that we had all kinds of water back here, we also had the issue of trying to figure out how to support this structure. Let's go look at what this soil looks like. But let's take a look down here at what the soil at this site was like. As you can see, it's a clay. And that clay undergoes severe pumping when it's too saturated and vehicles drive over it. Let's take a closer look at it and get that into focus, and you can see that it's a rather greasy clay. It's really sticky as well. I think if I remember right, I think we call this a brown clay. It has very little bearing capacity. That's the word I'm looking for. Like I say, it's a really sticky clay. And when we put our split spoon sampler into the soil, we found that the split spoon sampler didn't need to be driven at all. Or was it a Shelby tube? In any case, the clay has almost zero capacity for bearing. And so when we decided to put a structure on this, we had to figure out exactly how we could support the structure. So we're on the north side of the structure now, looking south, and we had to create the same kind of a cofferdam right about here on this side to keep water that had backed up from the reservoir into this area from flowing back into our project site. The biggest challenge on this project, besides keeping the water out of it, was figuring out how to create a stable foundation so that this box culvert didn't sink like the previous one. So once we had excavated and removed the original structure, we excavated a few more feet so that we could create that good foundation and then place the box on top of it. And it turns out that a four-sided box culvert is actually less dense than the soil that it replaced. And so with a good foundation and a less dense structure, we had a high degree of confidence that we wouldn't experience the same settlement problems even in an event like the flooding that we had in 2016. So much traffic. Underneath the box culvert, there are layers of triaxial grid and good fill, some structural fill, in about 3 or 4 different layers. I can't remember exactly how many, but we use that to create a really good stable foundation for the box culvert. All of that was done in conjunction with consulting with a geotech engineer, and installation of the sheet pile cofferdam had to take into account the fact that we had overhead power there, and so safety was also a major concern on this project. I think we've seen enough of this project. Let's go and take a look at another one. All right, wanted to show you a project here on 200 East. Come with me. There's a little diversion box down there, and it sends irrigation water through a pipe back underneath the park and then down along 200 East so that residents can get their irrigation water for their lawns. Pretty cool, huh? All right, back up here. Nice ornamental railing. Oh, turns out, here's the diversion I was talking about. Got a screen on it to keep debris out. And then this snazzy little bridge right here was designed by yours truly, as was the rest of the structures on this project. Well, sort of. And that's kind of what I want to talk to you about. So let's come up here for just a second. I'll get out of the rain. The things I do for you people. So you can see that there's a continuous retaining wall running all the way from one end to the other. And then up above are precast segmental arch pieces that were used to build the bridge. And then I'm next to a retaining wall that's underneath this fence. And then there's another wall underneath that side of the arch as well. And those walls I designed, and then we designed the geometry that was required for the opening both vertically and horizontally, so that this could be qualified as a federal trail. It has to be at least 10 feet wide. Excuse me. This one had to be 14 feet wide, and then it has to have a minimum 10-foot clearance 2 feet from the edge. So we designed this geometry, and then it was sent to a pre-manufacturer called Contec so that they could design the arch. We call that process a deferred submittal. So we're going to talk a little bit more about submittals as we go along, but a deferred submittal is basically when you design something, at least you set up the specifications, I should say, for that design, and then you send it to somebody else who does a proprietary design for it. And that's how we were able to use a product that requires a proprietary design, even though this was a publicly funded project. All right, let me jump back on my bike. Let's go look at some more. And this was also a deferred submittal design. And then right here you can see that they had to reconstruct a little bit of this wall. Right here they reconstructed it because that wall was deemed historic. Turns out that that aesthetic is used quite frequently in this area of central Logan. And that's why these pillars, as you can see there, also have that rock aesthetic. It's to reflect this historic retaining wall, and we call that context-sensitive design. All right, we'll look at that wall in a little bit more detail in a second. First, let's talk about the design bid build process. Let's say a client encounters a problem they can't solve on their own. They might hire an engineer to help them out. After having some discussion about what the design should include, the engineer will take those detailed notes back, knowing full well that they have way too much to work on, and enlist the help of their other engineers to help them design the project. Those engineers will develop the plans, specifications, and estimate, and then once they have those completely developed, they will help the owner bid them and get a contractor on board to build the project. The design bid build process is the traditional delivery system we've used to construct all types of projects for ages. In this system, an owner will contract with a designer to complete the plans, specifications, and estimate prior to separately contracting with a contractor to actually build the infrastructure. In this way, the owner retains a high level of control over the design, but they also have a high level of risk because any changes that occur during construction will be entirely the responsibility of the owner. As I said, since the contractor is only involved during construction, the designer can completely define the entire scope. This type of delivery system is best used using prescriptive specifications where we tell the owner, or rather we tell the contractor to do this, then do that, etc., etc. Significant risks or third-party issues like right-of-way acquisition or utility relocation or environmental impacts to the project can be resolved during the design phase prior to having a contractor involved, and in this way all of that liability is on the agency, but all of the control is on the agency as well. The advantages to this system is that it's really well established since almost all projects up until fairly recently were delivered this way. The other big advantage that this process has is that it delivers the lowest initial price, but the risk to that is that due to change orders or design errors or unforeseen circumstances, the ultimate cost may not be the lowest and the final design may not be the best value. So in this regard, changes to the project are usually quite costly. And the other big disadvantage to this type of process is that it can develop a potential adversarial relationship between the owner and the contractor because the owner is the one that calls for the inspection and the testing. And if there's disagreement about quality issues, then the owner and the contractor have to figure out how to resolve those. Let's go back to our project. Looking at the underpass from the north, we can see how some of this geometry all comes together, where we've got a wall, and we've got a soil mill wall, and we've got another wall, and then we have the arch, and we have very minimal cover over the top of the arch. so that we could maintain the grade of Center Street while also keeping the minimum clearance of the trail. And rather than having me talk about how this arch in this area was built, why don't I just show you? Hang on just a second. Because the volume of traffic on Center Street is fairly high, we had to minimize the disruption to traffic as much as possible. So once we stopped traffic, we quickly excavated the structure to prepare it so that it could receive a precast arch system. After chasing off the occasional looky-loo as well, and then also accounting for a utility, we placed the precast foundations, and then we placed precast arches on top of those foundations. Once those arches were in place and then grouted to be sure that they would be in the right position, we were able to start backfilling around the structure. Reconstruction of the road took place, and then the road was able to be reopened to traffic. This is a soil nail wall with architectural facing, and you can see, if I can get my finger in the right spot, right there. There's a joint running through it there, and then there's a joint down there. And we did that for thermal expansion and contraction. And then right down here we've got drainage. And that was also a deferred submittal. We told them that we wanted it to be, there we go, that height and have that geometry. And then we turned it over to somebody else who specializes in soil nail wall design, because again, it was a proprietary design. This curved wall here, however, and I realize from this point of view, maybe it's a little hard to see it's curved. Maybe if I follow the sidewalk, it's a little easier. That was an idea that we had, so that as you enter this, you've got a little bit better sight distance upon entering. And then right up here, you can see also that we've got security cameras, and then we've got emergency lighting in addition to the lighting that's always on. So we tried to make these things as safe as possible, and I think that we did a reasonably good job. All right, hang on, let's go look at this other wall. I jumped off my bike, and before we go and look at the wall, I wanted to show you these cool little benches. There's one here, you can see that there's one there, and then I think there used to be one right about where the entrance to the underpass is. But I just thought that that was a really cool feature that they put into this wall. They didn't really have to, but they did. All right, so the wall here, again, starting at that end, we designed the height, and it's really small down there, and then it gets to be a larger height as we go along. And then we designed these pillars, and we designed, as I mentioned before, the geometry for that arch. And basically we told them everything about the wall that we wanted, except for the smiley face, including that texture. And maybe you can see it well, maybe you can't. Let's zoom in here a little bit. So the texture there was also meant to kind of reflect the texture of that wall. Even though we couldn't do it to the same depth of relief as you might do on that wall, we still got some of that texture on there. And again, that wall, as I said, was a deferred submittal. And the reason that we did that was because MSC walls are also a proprietary design. So there are certain aspects of this that we designed, and there are certain aspects that were designed by others, following the required geometry and other specifications that we gave them. We wanted to bring pedestrians down here and then have them prevent having to go through this at-grade intersection, because pedestrian traffic conflicts can be a problem. So instead, we take them down the sidewalk and then around there, and then they go back up here under the tunnel and then go through and they connect on the trail there. And that trail then goes under the arch and under 200 East, and I'm going to say sorry now for not providing a great view of it from here. But that trail connects to trails over on 10th West, and this trail also connects to trails that go clear up into the canyon. So you can start your hike clear up there, sorry about that, but you can hike clear from the canyon all the way down through Logan, all the way down through this project, through the park, and eventually someday, when all of the funding is complete and the trails are built, you'll be able to hike clear over to the Wellsvilles way over there without ever setting foot on anything but a trail. I think that's pretty cool. Down this hill. Can't get this stuff off. Nasty stuff.
That's a good wall.
Yeah, don't tell Trump. You're still here? It's over. Go home.